Silakan.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih Pak Bagio atas perkenalannya. And I would like to say thank you to the Director General of ICT Application and also thank you to CICC for inviting us, NTT Data Indonesia, to share our knowledge and information to all of you. Saya mohon izin kepada Pak Joko, Pak Bambang, dan Ibu Tri, saya akan menyampaikan paparan ini dalam bahasa Inggris. So allow us to start our presentation. Shimada-san, please.
Cities all over the world are growing, and the complexity of society is increasing. As a consequence of this, we face new challenges within areas such as population, infrastructure, food supply, the environment, healthcare. To be able to face those challenges with confidence, we must look for smart solutions. NTT Data aims for the smart society. We search for the one smart solution with the ability to improve every aspect of your life. We strive to make smart connections between business, society, and people. In short, we aim to make everyday life smart and better. Connected data supports any business and industry. Your business decisions will be based on the best information available, always prepared and ready at hand. Smart devices provide convenience and flexibility anywhere and support you when things are changing fast and you need to be at your best. Charging to payment, from voice control to conversation analysis, navigation to opening your car door. All your personal and business information is now connected and follows you wherever you go, keeping you one step ahead. Whether it's a business meeting, picking up your kids, or going to a cozy family dinner, intelligent data will keep your schedule on track, and with intelligent data, you can always keep track of your schedule. Traffic is a huge and sometimes frustrating part of modern city life, but with intelligent route service, it's once again possible to enjoy driving while getting to the destination on time. In emergency situations, intelligent real-time traffic control can even save lives. When it comes to the physical infrastructure like roads, bridges, and tunnels, they require close monitoring to ensure that they stay safe. By using sensor technology, maintenance can be organized and delivered in time, preventing accidents while keeping us informed about the conditions of those essential structures. Invaluable information that is otherwise almost invisible until they break down. Kids grow up fast, and the time you spend with them is so precious. You want to watch your creative and globally minded kids closely as they grow and develop and take part in every important moment in their lives. And that's just one reason.
Ladies and gentlemen, what you are watching in front of you is our global company's vision of what a smart city and smart society would be like in the future. But in this wonderful opportunity, especially when Pak Bagio said I have a very short time, we would like to focus on machine-to-machine technology, where we in NTT Data believe that M2M technology plays a very significant role when we want to build and establish a smart city or smart society. But most over today, we would like to focus on social infrastructure, especially when you see around us there's like roads and bridges and many natural disasters happening lately, like floods. They have affected lots of damages on our social infrastructure, which has in return disturbed our economy and the social welfare. That is why we in NTT Data, we would like to introduce to you our M2M technology that can help maintain our vital infrastructure, including in places like metropolitans, including places like Jakarta. And I hope my presentation can also answer the concerns expressed by Pak Bambang, where we need to actually build the awareness of the human capacity, the human resources first. Why is it important for us to avoid reactive response and know the understanding why M2M technology or smart city is important for us. But allow us to continue until the end of this video. Thank you.
Technology cross-cloud creates an intelligent backbone for making businesses more profitable and for making society more efficient. A foundation to improve your everyday life, to make it easy for you to unleash your potential and to put a smile on your face. NTT Data will be leading the smart society.
So before we go into our explanation about M2M technology and about our solution for infrastructure management, I'd like to briefly introduce to you our company, NTT Data Indonesia. So maybe some of you have known that NTT, we are now the second biggest telecommunications company in the world, and the Fortune Global 500 in 2012 has ranked us as 29th largest company in the world. And NTT Data, we are one of the core members of the NTT Group, and we are an IT service provider and also a system integrator, and we have been established since 1967. And just recently, in 2011, we also opened a representative office here in Jakarta. So now our global team is supported by 61,000 personnel, and we have actually built a control network and operations that covers from North America, South America, China, Asia Pacific, Europe, Middle East, and even Africa. And now even in Jakarta we have 50 members, but we are now continuously growing in line with our introduction of our solutions here to Indonesia. Next, Shimada-san, please. Now, in short, about what is M2M technology, or machine-to-machine technology. So originally, M2M means a system that connects and can automatically and optimally control machines without human intervention. So there's an exchange and transmitting of data and information between one device or one machine to another device without human intervention. So the purpose is actually to minimize human error that may occur. And some have also defined M2M as a bidirectional communication service using a fixed or radio network between a remote equipment. But we in NTT Data, we simply interpret it as exchanging with machines via network. And you can see in front, there's lots of machines. There's a vending machine, even an electric car, a telephone, and even electric home appliances and sensors. They transmit data to another machine or even relay it through a server, and then that server will also relay information back. And the information is what the users will need or desire, or even the information can actually command another machine to conduct a certain task. So that's in brief what M2M technology is commonly known about. Now in NTT Data, we have applied M2M in many sectors, in many different sectors. We have applied it in disaster preparedness, transportation, and remote control. But as what we mentioned today, we would like to focus more on infrastructure management. And one of our continuously developed solutions is our bridge monitoring system. So maybe all of you are aware that there's many bridges being built now, and I think Jakarta is very proud. Just in December, we opened the non-toll flyover, one of also, I think, an achievement for the public works here. And every day, actually, we cross bridges and cross flyovers. And the thing is, when we talk about bridges, it actually has developed from era to era. Now it's becoming more and more complex. It's becoming landmarks, and the architecture and design is being more complex. We pass it every day. And I don't know in Indonesia, there hasn't been any figures, but in the US alone, it is estimated that there are 3 billion crossings of bridges every day. So this goes to show how bridges, other than it assures connectivity, and it helps us communicate with one another, but it does have a very great impact on our social and economic welfare. That's why it is very important for us to manage and maintain those bridges. So we cross them every day, but we always take them for granted. We never think whether it's safe or not, and sometimes they do fail us. Now, before we go on further on explaining to you, I have some data regarding the situation in Indonesia, but I'd like for us to take a very short glance of the situation of infrastructure in Japan. So the Ministry of Land, Infrastructure, Transport and Tourism, or MLIT in Japan, records that there are approximately 155,000 national bridges. But more than a third of those bridges were built in the years of 1960 and 1970. Why? Because in 1960s and 1970s, perhaps my Japanese colleagues also know this, it was the rapid economic era. So there was a high economic growth and lots of investment was put in the sector of infrastructure. But now it's 2014. And it's estimated that around 16% of the existing bridges have passed more than 50 years of construction. And even MLIT estimates that by 2030, more than 50% of those bridges, or around 80,000 locations, will pass the 50-year mark. And many of those bridges only have a lifespan of 50 years. So this goes to show that with the aging bridges, and they also show signs of bridge deterioration or bridge degradation. And in addition to the aging factor, Japan is also frequently hit by earthquakes, which have also caused many severe damages, not only on the bridges, but the roads, the tunnels, and other vital infrastructures. And it is very sad for me to share this information, but in December 2012, in a highway tunnel in the Yamanashi prefecture, the tunnel collapsed and it killed 9 people. There was actually an inspection already done in September 2012, but the results show that there has been no reinforcement or strengthening ever since it was built in 1977. So this is just one example of how critical aging infrastructure and poor maintenance is actually existing in Japan. And that is why many experts are now saying that Japan is unfortunately facing an infrastructure crisis. Now, how about the rest of the world? How about other countries? So I'm showing you here, unfortunately, 3 pictures. Now, I don't know whether some of you here know what these 3 pictures describe, but the 2 top pictures actually happen in the United States. We think they're a super economy and one of the major spenders in public works, but it turns out that just in 2002, the left side picture there, that it was an Oklahoma bridge tragedy, killing 14 people. And also the right picture there, it's a bridge collapse in Minneapolis, killing 13 people and injuring hundreds. And it turns out that even in America alone, 500,000 bridges exist, but a third of them require strengthening and repairing, and it's estimated $70 billion is needed to recover those bridges. And also the bottom part, maybe this also recalls your memory, still fresh in our mind. It happened in Kalimantan, that's the Kutai Kartanegara Bridge. Unfortunately, there were 24 fatalities. This happened in November 26, 2011. And after investigation from several universities, it turns out there was a clamp that was broken and it was undetected. So there's bridge experts and engineers around the world are agreeing that many bridges are experiencing severe bridge deterioration and require immediate attention. Now, like what I promised you, next slide please, Shona-san. This is some data we have from Indonesia. We compiled this from Bina Marga. I don't know whether any Bina Marga representatives are here, but based on the data from the Ministry of Public Works, it is recorded that Indonesia has 21,371 bridges on national roads with a total length of 404 kilometers. But when we classify based on the construction years, it is quite different with Japan, because there is like a even trend throughout the decades. But if we count from those, from that data, we can see that more than a third of those bridges are built in the 1960s and 1970s. This means that many of our national bridges, and maybe some of you have crossed those bridges this morning, are also reaching the 50-year mark, creating issues of deterioration. And with that example, and also the unfortunate picture we showed you in the previous slide, it demonstrates the potential dangers of aging infrastructure. So after we've explained this to you, I think it is time for us to actually ask us the same question. And what is that question? Shimada-san, please. Thank you. Is Indonesia facing an infrastructure crisis or not? It is not within my authority or capacity to answer this, but let us look at some more figures and see how we feel about Indonesia. So 53%, I don't know if anyone knows what 53% here means. It is not the threshold of our national election, but 53% is related also to infrastructure. So there's actually 53% of bridges in Indonesia based on our annual inspection that are considered in damaged condition. Now there's another also significant number, 32%. Now what does 32% represent? 32% represents the number of bridges in Indonesia that is estimated to collapse in the future if there are no repair or renovation undertaken. So yes, this is a very sad situation. But I've told you a very long explanation about the problems. Now let's think about the solution. We have to ask ourselves, what is actually needed? Now we in NCT Data believe that what is needed is actually effective bridge preservation through way of having a reliable bridge monitoring system. Because we believe that when we talk about effective bridge preservation, to achieve that, operators and engineers will indeed require accurate data and information to build and plan an effective maintenance program. Thus, we think that a reliable bridge monitoring system is needed to ensure that all necessary data is measured and collected. But before I move on to what we mean by a bridge monitoring system and the core technologies of a common bridge monitoring system, I'd like to explain to you why is a bridge monitoring system so important. So in the past, when we talk about bridge maintenance, usually it's started or it's instigated, triggered by bridge inspection, meaning that there's an examination of bridge conditions that occurs at a predetermined time. So like Indonesia, Bina Marga sets out bridge inspection once a year. In Japan, it's actually once every 2 years. And that triggers, or the data collected from those bridge inspection is what is used for bridge maintenance. However, there are some downfalls. Because when you talk about, let's say for example, a crack can happen in counts of days. If you wait for 1 or 2 years to do an inspection, that crack can become a big hole, can become a big fracture. Now, that's why we think that if you complement, we're not saying we're replacing bridge inspection, but if you complement bridge inspection with a real-time, day-to-day bridge monitoring, that will actually provide you with more accurate data so you can conduct and carry out immediate steps and not have, what Pak Bambang mentioned, a reactive response to every incident. So now, of course, around the world, our governments are starting to plan their bridge maintenance based on bridge monitoring results. So based on that explanation, we can conclude that with bridge monitoring, it can help us understand better the integrity and the conditions of our bridge structure. Once we are able to understand better our bridge structure, we are able to plan a good bridge maintenance, and that will ensure, again, our bridge safety. And of course, when we talk about bridge maintenance, of course, we think about investment and cost. By ensuring the bridge safety, which means we can maintain the utilization of that bridge, meaning that we can optimize the operation cost and also the investment. And in the end, this is what's important. It maintains and extends the lifespan of bridges. Okay, now just in brief, Bina Marga also classifies bridge preservation into 4 main levels: routine maintenance, periodic, special maintenance, rehabilitation, and replacement. So, please next. Yes. So we here in NCT Data believe that with a good, reliable bridge monitoring system, we can maintain the level of maintenance at the first 2 levels or phases, which is routine maintenance and periodic special maintenance, which does not require major overhaul or major cost and investment compared to doing rehabilitation and replacement. With rehabilitation, sometimes you have to close the access, allocate many resources, and with replacement, if even rehabilitation cannot fix the problem, then what's next is demolish it and then have investment to build a new bridge. Not many governments have that money, not even the United States, not even Japan, and I believe it will also be difficult for Indonesian government. So we think that with a good, effective preservation through reliable monitoring system, we can not only ensure bridge safety, but we can save our time, save the risk, and also save our investment. So now going to what we think is also the core of this presentation is bridge monitoring system, or what is commonly known worldwide as structural health monitoring system. Because when we talk about monitoring a bridge, it's more about the health integrity of the bridge itself. And now, all over the world, they are now implementing the M2M technology, where installation of sensors that can capture data in real-time manner, relay it to a server, and then relay it to a data center, which can be viewed by operators and engineers. And that's why M2M technology has provided a very significant development to how we conduct monitoring of structural health. Next, please. Thank you. So what is the core technology of an SHMS system, or structural health monitoring system? As you can see here, these are actually the key sensors that we place in a structural health monitoring system. You can see up front also there's some graphic to explain what it means by displacement. So we have what we measure in the structural health monitoring system. First is the displacement. If there's any moves happening or occurring on the critical elements or parts of the bridge, that's why we also install a displacement sensor. And then second there in the middle is we have to measure and collect data regarding the vibration happening or occurring. That's why we also apply or install accelerator sensors, that's to measure vibration and dynamics. And third there is one of the basic data that we have to collect in an SHMS system is the strain or the stress level of the bridge. That's why we also apply many strain gauges or strain sensors. Meanwhile, on the far right, those are two additional but also important sensors, which is a high accuracy GPS. So if there is a displacement, we know initially it was at a certain waypoint or a certain point in the GPS, and then it moves to a certain point. That's why it's important also to have a GPS, a high accuracy GPS device. And also for bridges located in areas where there's extreme weather conditions, we also apply meteorological sensors. Why are these sensors installed? Because let's go back to think about what affects a bridge itself. So in general, bridge experts and engineers agree that there are three main factors that affect the bridge. First is extreme weather conditions, second is the heavy traffic, and third is the load of the structure itself, because a bridge without any cars passing by, it itself is very heavy. But now looking into Indonesia, we have some additional contributing factors that maybe are not common in other parts of the world. One, we have extreme mother nature or extraordinary mother nature events, such as earthquakes and landslides. And second, we have very extreme traffic load. Maybe in other countries, you have roads designated for certain tonnage, but here in Indonesia, usually that one single road, containers pass by, 1 ton, 3 tons, motorcycles pass by. It's heavy traffic passing those roads. And second is land subsidence or land sinking. That's also one additional problem that we find for our vital infrastructures. Now, from those factors affecting a bridge in general, that is why these are the basic data that is very important when we want to monitor the health or the integrity of our bridges. Next, Shimada-san, please. Now, these are the features and benefits of an SHMS system using M2M technology. We would like to illustrate this to you based on our product, which we call bridge monitoring system. So there are two main key features of our bridge monitoring system. One is structural defect detection, which provides a statistical data analysis. And second is the overloaded vehicle detection. So for the first one there, but let me explain to you that when we talk about a bridge monitoring system or an SHMS system, there are three main elements to it. One is the sensors itself. Two is the data acquisition hardware, which collects data from sensors. And three is the software, which interprets all those collected data and provides information on the health of the structure. Now, what we're illustrating to you in front here is what the software or a common bridge monitoring system, especially our product, this is what it can provide. These are the key features. So talking about structural defect detection, a bridge monitoring system, it can measure all the changes, vibration, level of stress, displacement in real-time manner. And then from those changes, we can also know the list of damage alerts. using a GIS approach, we are able to map out where the locations of the damages are happening. If there's a crack on a pylon, on the tower, or on the beam, we can know where it is located. And then third is that using a bridge monitoring system, we are able to also provide a 3D graphic of the motions itself. And all of that is also provided in statistical data in every time interval. The most interesting thing about bridge monitoring system, this is something I also just found out a couple of weeks ago, is that in just a matter of seconds, it can generate thousands of data because you have multiple sensors working together and collecting data at every second. So the second key feature here is overloaded vehicle detection. And I think this will be very useful for our law enforcement, for our police, because when we talk about bridges, sometimes it is only designated for certain tonnage, but lots of high weight or heavyweight vehicles pass by. Using this real-time monitoring, we are able to know and detect the vehicles passing by. And we are able to measure the daily traffic volume. And also, this is very interesting, it can also provide us information on the accumulative damage. So all of this information is then connected to a data center, which the operators, engineers, and also perhaps the disaster mitigation, Badan Penanggulangan Bencana, can also utilize and benefit from information we have in our bridge monitoring system. We know before anything worse or critical happens. So to share with you our key projects and experiences, recently in 2012, with the completion of the Tokyo Gate Bridge, we also implemented our SHMS system. This bridge is in Japan. The data that we collected was for strain data, vibration, inclination, and displacement. The main sensors that we place are accelerators, strain gauges, thermometers, and displacement meter. We believe that one of the key benefits is we are able to detect the abnormality and also plan an effective maintenance. And next is our example. This is from our neighboring country in Vietnam. This was also a signature landmark for the Vietnamese people. It's the Kanto Bridge, also finished construction in 2013. We implemented and introduced our structural health monitoring system there. It's the first structural health monitoring system that the Vietnamese government has. And also, those two examples are the new bridges, newly constructed, but like what I told you in the beginning of my presentation, mostly our concern is aging infrastructure. And that is why NTT Data, in collaboration with universities and other institutions, we try to implement in also existing infrastructures like the Osaka Bridge, Tamagawa Bridge, Arakawa Bridge, and in Yokohama Bridge. And also we implemented it in several expressways. And other than Japan and Vietnam, we have also introduced our system to China. So that is, in brief, our solution for bridge monitoring system. Before I end, unfortunately, I think I'm also running out of time. I'd love to share many more information with you, and perhaps outside of this forum, I'd be happy to answer any of your questions. But again, before I end, I'd like to show you a video that we made in Vietnam that shows you the Kanto Bridge. And this also has some short pictures about the data that we collect and the image of the data center that we built in Vietnam. Please, Shimada-san. I apologize, it's in Japanese.
ここでは振動や歪みなどのデータをセンサーで常にモニタリングし、異常を検出するシステムを導入。安全な車両の行き来とベトナムの人々の安心に一役買っている。Data for the people, LTT data.
So again, thank you once again for this wonderful opportunity. Thank you to the Director General ICT Application and to CICC. We look forward to hearing your feedback and challenges. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih pada Ibu Dia. Silakan duduk kembali.